Hello students. So we have next topic in this introduction to energy sources and its conversion, that is geothermal power plant and windmill. That is by using wind energy, we can convert wind energy into electricity or electric power. So we'll see this geothermal power plant and windmill in this video. So first we'll see what is meant by geothermal energy, and then we'll start with geothermal power plant. So geothermal energy, it is nothing but the energy which is lying within the earth. That energy is called as geothermal energy. So there occurs in this geothermal energy, there occurs a steam and hot water which is at about 200 to 300 degrees Celsius inside the core of earth. And this energy, that geothermal energy, it is visible to us by using volcanoes. So by, if there is a volcano happen, then this geothermal energy is visible to us. Otherwise it is very deep inside the earth. Now, there are two methods to convert that geothermal energy into either power plant or electricity. The first method is to transfer heat lying inside the working fluid. The first method is to transfer heat which is lying inside the earth to the working fluid which operates in a cycle in an area where this volcano activity is arrived. By using coils of pipe are passed deep inside the earth surface, and the water is sent to this pipe, and then this water, that heated water, it again raised to ground and it is get passed to the heat exchanger and boiler and all other parts of the uh, thermal power plant. So this is the first method, that is we transfer the pipe inside the working fluid which is operating in a cycle. In that the pipe, in that pipe water is circulating and the heated water get out from that, where we can convert this geothermal energy into the heated water, that is we can say a heat energy or thermal energy of the water. In second method, the hot water or steam, this steam is directly operates the turbine nearby the area, that is almost in between 3 kilometers away. So this is the second method, that hot water or steam coming from that geothermal or core of the earth, it is directly passes to the turbine. This is the second method. So this geothermal energy is exist in United States of America, Japan, New Zealand, Mexico, Italy, and in India we have Himachal Pradesh, where this geothermal energy is found in abundance. So a thermal power plant needs steam to generate the electricity. So the steam rotates the turbine, and this turbine is coupled to generator which produces the electricity. So the geothermal power plant is also works on same principle as that of the thermal power plant. But the only steam is produced without heating of the water from coal, diesel, or from nuclear reaction. It uses a steam produced from reservoir of hot water, which is found inside the earth surface. Okay, so it is inside very deep, that is couple of miles or more than that, that energy is available. So these are there are three types of geothermal power plants based on this energy, that is called as dry steam power plant. Then second one is flash steam power plant, and third one is binary cycle power plant. So these are the three power plant which is based on geothermal energy. So we'll see this power plant one by one. So first power plant, this is a geothermal energy. It is available. It is the first method where heat exchanger device will be there which exchanges heat, and that heat is again transferred to the turbine. So if you see, there is a geothermal zone is there. So inside that, the geothermal or working fluid is there. So we supply this geothermal fluid is there, and the pipe, the working fluid or geothermal fluid, we have two type of well is there. One is injection well and another one is production well. So from production well, we pump this geothermal fluid inside the pipe. There is a heat exchanger device. So heat energy of this working fluid, it is transferred to the water, and the water becomes steam. So remaining uh, the remaining the heat energy gets rejected in this heat exchanger devices, and again this fluid is passes through injection well inside this geothermal zone, and again it gets again heated, and similarly it gets again pumped by using pump. So every time this geothermal fluid, it gets through a cycle, and in every time by using heat exchanger we can convert this heat of geothermal fluid to transfer this heat into water, and water becomes steam, and all other parts are same as that of the thermal power plant. Now we will see the first power plant based on geothermal energy, that is dry steam power plant. So the diagram for this dry steam power plant is shown in this figure. So we have production well and injection well. So from production well, the working fluid is passes, and directly it is strike on a turbine, where turbine gets rotate, and because of that generator will generate the electricity, and the remaining fluid it get again passes through the injection cell. It is called as dry steam power plant. So a dry steam power plant draws from underground resource of steam. So from that underground, we draw a steam. The steam is piped directly from underground wells to the power plant, where it is striking or directed towards the turbine and generator as shown in this figure. So directly we pump the steam by using pipe, and it gets passed to the steam turbine. The rest of power process, that is generator is there, which convert your mechanical energy into electrical energy, and then the electricity distribution is there. So the rest of power production process is same as that of thermal power plant. The geysers, or we can say geysers, is one of the example of dry steam power plant in Northern California. So this type of dry steam power plant, it is available in Northern California, where by using the steam, that is dry steam, we convert that thermal energy of steam into an electrical energy. So this is the first type of power plant, that is dry steam power plant. Second power plant based on this geothermal power plant, it is flash steam power plant. So it is the same process as like a dry steam, only difference that there is a flash steam. Now what is meant by flash steam? So flash steam power plants are the most commonly used the geothermal power plant. Because this geothermal reservoir of water, it has a temperature greater than 182 degrees Celsius. And this hot water flows through the wells in the ground due to its own pressure, and it flows upward. The pressure decreases and the hot water boils into a steam. So by its own pressure, the water gets inside to this geothermal or geothermal layer. It is injected inside that layer. Then it gets heated. Now, if it is heated, its density goes on decreasing, and the water becomes steam. And this steam is then separated out from the water in the flash tank. In earlier, that is in dry steam, there is a dry steam directly is there. So there is a heat exchanger device, and from that, the directly dry steam is passes to the steam tub. Here, we separate out the water content in this steam, and that steam is used to rotate the blade of the turbines. Then again, this turbine is coupled to the generator where the generator produces the electricity. Again, the separated water from this steam and the condensed steam, they are injected back into this geothermal layer, where again that can be heated, that density again reduces, and it can be converted into a steam. And again, the steam is separated from the water and it is gets passed to turbine. So that cycle goes on repeating every cycle. So this is the second type of power plant by using geothermal energy, that is the flash steam power plant. Now we have a third power plant which is based on geothermal power plant, which is works on a binary cycle. This binary cycle, that is first diagram I have shown, that there is a heat exchanger. It is based on binary cycle power. So in this power plant, a binary cycle power plant, it operates on a water at lower temperature, that is between 107 degrees Celsius to 182 degrees Celsius. Now for flash power plant, we require temperature more than 180 degrees Celsius. For dry power plant, we require temperature more than 200 to 300 degrees Celsius. But in case of this binary cycle power plant, we require temperature up to 107 degrees Celsius to 182 degrees Celsius. So there are two cycles of this binary cycle power plant. So the heat of hot water, that is underground water, is used to heat or boil the working fluid. Usually it is an organic compound which has a low boiling point. So the working fluid gets vaporized in heat exchanger, and that will be used to rotate the boiler as like butane boiler. So that will vaporized at very low temperature. Similarly, there are other types of organic compound which has very low boiling point. So it becomes vaporized early. So the water is then again injected back to the ground and again get reheated, and the water and working fluid are kept separated during this whole process. So this is a working fluid. So here is a heat exchanger. So this is the working fluid is there. The working fluid passes to this turbine, and here is a water. So water is passes through this. So we get water circulating through these pipes. So heat exchanger is a device which converts or transfer the heat of this water to the working fluid. Then working fluid becomes vaporized, and it is then passes through the turbine, which rotates the generator, and we get the electricity. So there are two cycles of this binary cycle power plant. One cycle is ground hot water, and another cycle is of working fluid. So this cycle is of working fluid, and this cycle is of underground hot water. So because of this, there are two cycles. This power plant is called as binary cycle power plant. Many geothermal reservoirs that are located in western states of America, then Alaska, Hawaii in United States, they are based on this binary cycle power plant. So this is the diagram for binary cycle power plant. So this is the geothermal layer. This is the injection well, where the water get injected, and from this production well, the hot water gets out from this production well, and it transfer its energy to the working fluid, and this working fluid is gets vaporized, and it get strike to turbine, and we get the rotation of the turbine, and we get the electricity by using generator. So we convert this mechanical energy of turbine to the electrical energy by using generator. So this is about geothermal energy, and there are three types of power plant based on this geothermal energy. One is dry steam power plant, where we use dry steam directly passes to the turbine. Second, in case of flash steam, we have a flash tank where steam gets separated from water, and water gets again passes to the injection well, and the remaining steam is passes to the turbine. And in case of binary cycle power plant, there is a heat exchanger device which exchanges heat between ground hot water and working fluid. So this is the binary type of geothermal power plant. Now we will see some advantages and disadvantages of this geothermal energy. So it is a reliable source of energy. Geothermal energy, it is a reliable source of energy. From this geothermal energy, no harmful emissions will be there. Then efficiency is very high, maintenance is required very low. Then there is no external source required to keep plant running, and power station are very small. Now disadvantages is there. There is a possibility of depletion of these geothermal sources. Second one is it requires very high investment cost, and also this geothermal energy is difficult for transportation. And generally, this power plant is close to the volcano activity. So if there is a volcano happens, then this power plant may become stop suddenly. So these are the some advantages and disadvantages of geothermal energy. Now we will see the next type of energy, that is wind energy, and the power plant using this wind energy, which is called as windmill. So we know that the wind is a result of sun's uneven heating. So because of sun uneven heating of the atmosphere, it produces the wind. So because of this uneven heating of the atmosphere, warm air gets expands and it gets rises, and cool air contracts and it gets sinks. So this movement of air is called as a wind. So this wind is used as energy for the long time. So this wind energy is used to pump the water, to power the ships, and also to power the mill grains. This wind energy required area with constant and strong winds that can be used by a wind turbines to generate the electricity. If we have to generate the electricity, we require constant and strong winds. So the major drawbacks of these wind power generators is they require lots of open land and fairly constant supply of wind. That is the main requirement of this windmill or wind power plant. Also, windmill, it is a noisy, and some people consider that these windmills are aesthetically unappealing, and because of that, it produces some visual pollution also. So this is one of the key area of concerning this windmill. Now, if you see in windmill, the wind flow pattern is vary from place to place. So, and it is affected by bodies of water, vegetarians, and different terrains. So, wind is nothing but the movement of air from one place to another place. So, windmill harnesses this wind speed and convert wind into a power generation. So the wind rotates the blades of windmill, which is mounted on hub of propeller shaft. Then this rotor is coupled to the generator, which converts the mechanical power of rotor into electrical power. So this is an windmill. Now we'll see this windmill. So if you see this windmill, this has this nine mains component. So first is your rotor with blade. So this is a rotor part, and these are the blades. So there are two blades or three blades that are generally used in this power plant. Now there are two types of windmill. This is horizontal axis windmill, and there is another type of windmill that is called as vertical axis windmill. So this is horizontal axis windmill. Why? Because this wind is at horizontally, and the rotor is rotated the horizontally. So all other components are horizontal, and rotor is rotated again horizontal. So this is the horizontal axis wind turbine. So first component is rotor. So this part is rotor, and these are the blades. Second part, it is electromagnetic brakes, or we require brakes. It may be either mechanical brake, electromagnetic brake, or it may be electrical brakes. Then third, we have mechanical brakes. Then fourth part, this part is your gearbox, where we convert or we increase the speed of rotor. So this rotor speed is of 30 or 60 RPM is converted into 1000 or 2000 RPM by using gearbox. Then fifth component is your generator. Sixth component, it is flap or tail vane. Seventh component, it is tower top, where all these component uh, it is founded on this tower top. Then we have shaft. So this is the shaft part, 8. And ninth, it is yaw control mechanism. So which controls the brakes and all that there is there. Controlling of this windmill by using yaw control mechanism is there. So if you see, there are main components of, or we can say major components of these windmills are blades. Then we have rotor, then gearbox, tower, anemometer. These are the some parts of the main components of the windmill. Now, what is the windmill? Windmill is a device, or it is a device which converts wind's kinetic energy into an electrical energy with the help of blade and generator. So kinetic energy of wind is strike on this blade, and by using generator, we can convert this kinetic energy into electrical energy. Now the winds gets flows over this aerofoil shape of the blades. So generally blades is of having aerofoil shape that creates the lift and causing them to rotate. Because of this wind, it causes these blades to rotate these blades. And in this process, the winds gets slow down from this position to this position. From this to this, when it strikes to these turbine blades, the wind gets slow down. Now these blades are connected to this shaft that rotates the electrical generator, and we get the electricity. Then the power of this windmill is calculated by using this formula, that is 1 by 2 rho A into V cube. So power of this wind is proportional to the area. Then it is proportional to the area of windmill being swept by the wind. So जितना ये एरिया ज्यादा होगा ये ब्लेड्स का, उतना उसका पावर ज्यादा होगा, पावर कैपेसिटी ज्यादा होगा. Second, it is proportional to the cube of wind speed. So wind speed is very much important. And the next one is air density. Now air density is constant. It can be varies little bit at some high altitude level or low altitude level. So mainly it is based on your area and volume. So this is the power. So power of this windmill, it is proportional to the first area, then cube of the wind speed and the density or air density. Now we will see the different parts of these are the working principle behind the windmill. Now we will see the different parts of this windmill and the function of this windmill. So the first part is blade. So blades, they are lifts and rotates when the wind is blown over them, that causing rotor to spin. And most turbine, that is most windmill, have either two blades or three blades. So this is the first part of the wind turbine, that is the blade. Second one is brake. Now brake, it is used, it may be either electromagnetic brake or mechanical brake. It is used to stop the rotor in case of emergencies. So the brakes is used to stop the rotor mechanically, electrically, or by using hydraulically in case of emergencies. Then we have controller. So controller, it is a device. It start up the windmill or machine when wind speed is 8 to 16 miles per hour. Then it shut offs the windmill when it goes about 55 miles per hour. And turbine or windmill is do not operate when it goes above 55 miles per hour, because if we run this turbine or windmill based on this above this 55 miles per hour, then they will damage this high velocity wind. It will damage the mechanical parts of this other parts of the windmill. So it starts when the velocity of wind is between 8 to 16 miles per hour, and it shut off when the machine, the wind velocity is about 55 or more than 55 miles per hour. Next part is gearbox. Now this gearbox connects the two shaft. One is low speed shaft of from the blade or rotor, and second shaft, it is connected to the generator. So it connects low speed shaft to the high speed shaft. So low speed shaft is of the rotor of the blade, and high speed shaft, it is the shaft of the generator. So gearbox increases the rotational speed from 30 to 60 RPM, that is rotation per minute, to 1000 to 1800 RPM. So this is the rotational speed required for most of the generators to require or to produce the electricity. So by using this 30 to 60 degree, 30 to 60 RPM, we cannot rotate the generator. So for that, we required minimum 1000 to 1800 RPM so that we can rotate the generator, and from generator, we can produce the electricity. Now the gearbox is a costly part and also a heavy part of this wind turbine or windmill. And the engineers are exploring these direct drive generators that will operate at a rotational speed, low rotational speed, and we does not require a gearbox for that. But it is not possible up till now. So we required a gearbox as well as the generators. Now generator, it produces 60 cycles, or we can say 60 hertz AC electricity or AC electrical energy. It is usually an off the cell induction generator we used. Then a knuckle, it is a part, it is not shown in this diagram, but knuckle, it is a part where it is a large space pass. So this part, it is called as a knuckle, where all these component, it get. So knuckle sits atop the tower and contains gearbox, low and high speed shafts, generator, controllers, brakes. Okay, so all these parts, it is enclosed by a device. That device is called as a nacelle. So some nacelles are large enough where we can land helicopter on it. So these are the some basic parts of this windmill and the functions of the each part of the windmill. So this is all about the two types of energy. One is wind energy and second one is geothermal energy. Okay, so this is all regarding this unit number one. Uh, in windmill, we have a problem that is asked on this to generate what will be the power, then what is the area. So based on this, we have a problems or numerical based on this windmill that we will see in there is a numerical based on pumps, turbines, windmill. So that in that numerical, we will see this numerical of this windmill. So thank you for watching this video, and also uh, please subscribe my channel so that you get the updated videos on this channel. So thank you very much for listening. Thank you.